October 14th, 1944. 5:30. Rain hammered the tin roof of a low farmhouse outside La Haye Sainte, 12 kilometers south of Mons. Dawn bled gray across frozen furrows and hedgerows. Emil Kessler stood at the back porch, binoculars fogged, fingers smelling of oil and harvest, listening as the earth itself began to speak, the distant metallic growl of track giants approaching. Local witness statement, October 14th, 1944. At 6:12, the silhouettes crested the ridge. 12 Tiger Eye heavy tanks in column, long-barreled 88mm guns leveled, commanders peering through hatch slits. Their interleaved tracks chewed sod into ribbons. Radios hissed terse commands. To the German crews, this was routine, a deliberate advance to secure a withdrawal corridor. Wehrmacht unit log, October 14th, 1944. Emil was no soldier. He had tilled these fields since boyhood and buried kin in earlier wars. In a cobbled barn, under a stolen lantern, he and a small circle had built something. A field contrivance from scavenged ordnance, a tractor winch, copper tubing, and a reagent taken from an abandoned bottling works. It was crude, hidden, and engineered with stubborn care. Local machinist note, October 1944. The first engagement was sudden. Sharp reports detonated along the lane as the lead tanks rolled over disguised devices. Torsion bars snapped, skirts split. 3 Tigers halted. 2 caught fire. Men tumbled into the rain, faces white, boots slick with mud. Radio chatter, once confident, frayed into confusion. Company after action, October 14th, 1944. A commander on an immobilized tank climbed the turret and pounded his fist on plate, as if force could beat sense into malfunction. His voice flowed across the field in curses, later recorded as stunned disbelief. Dramatized composite. How can a field do this to steel? Field interrogation notes, 1944. Allied scouts noted the spectacle 2 hours later. 12 heavy tanks engaged, 6 immobilized, 2 burning, cause unknown. Official reports recorded the outcome clinically, but eyewitnesses remembered a single farmhouse, a man with a wrench and a chemical tang in the air. Allied Recon Notebook, October 14th, 1944. This was not sorcery. Emil exploited a brittle axis in armored warfare. Maintenance-dependent elements, rubber, seals, fuel lines, vulnerable to corrosive attack and mechanical sabotage. Commanders counted armor and calibers. They sometimes forgot the soft underbelly that makes a tracked monster mobile. Armored Warfare Doctrine Brief, 1943. The device was a barn-made synthesis, a pressurized dispenser fashioned from an illicit canister, metered tubing, and a time-release trigger by a tension wire. A machinist who had worked in Charleroi munitions line taught Emil where a Tiger's rubber edges and fuel feeds were exposed. That knowledge turned scrap into a precision tool. Technical note, October 1944. When alarms rose, the Germans attempted maneuver and retaliation. They fired into hedgerows, burned back fields, and tried to tow the dead with heavy winches. Engineers crawled over treads prying at buckles. Orders filtered back. Technical unit required. Bring specialists. The recommendation arrived minutes too late. Regimental comm log, October 14th, 1944. A regimental memo later that day noted evidence of local engineering sabotage, civilian workforce involved. Regimental intelligence summary, October 14th, 1944. For men raised on doctrine, the idea that a farmer could weaponize chemistry and scrap into a force multiplier was both infuriating and terrifying. It suggested the front was porous in ways maps did not reveal. By 9 o'clock, 6 Tigers lay crippled. Soldiers looted while others kept watch. Allied units cataloged the wrecks and filed photographs that would be referenced in post-war assessments. Allied unit report, October 14th, 1944. Emil walked among the smoking hulks with a small tin of tools and the slow gait of a man who knew consequence. He did not rejoice. He had built to protect his land and the broken lives upon it, not to be a legend. His fingers trembled from months of secrecy and sleepless labor. Local witness statement, October 1944. The tactical picture was stark. A dozen heavy tanks removed from the order of battle in a single morning, not by air or artillery, but by patient local ingenuity. Casualties were modest, but the psychological toll leaked into radio rooms and mess halls. Commanders whispered about the countryside itself being a threat. After Action Civil Report, October 14, 1944. What the Germans could not yet piece together was the principle behind Emil's work, an economical method targeting mobility rather than armor, turning logistical fragility into battlefield effect. It forced technicians in high command to look beyond calibers to chemistry and to ask awkward questions about factories, reagents, and black market chains that fed a village barn. Industrial Note 1944. That evening an order rippled outward from headquarters. Find the source. Send engineers. Secure supply lines. Specialists would be dispatched. Printers would hum as directives were typed, and men with calipers would be sent to interview a farmer who wore no uniform. High Command Cable, October 14, 1944. Nearby, divisional logs later recorded unit names. Panzer Regiment 502, 3rd Company advancing under Oberstleutnant Franz Roeder. Timestamps show frantic messages 6:45 to 7:30, reporting immobilizations and emergency tows. Panzer Regiment 502 log, October 14, 1944. Allied intelligence annotated maps with hash marks where derelict Tigers lay like carcasses. Photographers took frames of bent road wheels, corroded hoses, and scorched engine grates ordnance officers would study. Photographic reconnaissance, October 14, 1944. The investigation would unspool secrets, and the next morning's briefings would change everything across Europe. Provincial Inquiry Note, October 1944. By dawn the following day, word of the Tiger massacre had spread across Allied command posts like wildfire. Reports arrived describing a single Belgian farmer who had halted an entire armored column with homemade devices. Officers scoffed at first, then sent for the wrecked photographs. What they saw defied conventional logic. Tiger split open not by shells, but by ruptured seals, blistered metal, and warped lines, as if the tanks had melted from within. U.S. Army Intelligence Summary, October 1944. Investigators swarmed the site. Lieutenant Harold Pierce, an ordnance engineer from Detroit Arsenal, knelt beside one ruined Tiger and scraped a sample from its suspension joint. "This isn't shrapnel damage," he murmured. "It's corrosion under stress." The samples, when tested, revealed traces of oxidizing agents combined with hydrocarbon accelerant, a crude but deadly concoction that attacked the Tiger's rubberized fuel components. Technical Manual TM9 to 294, 1943. Emil Kessler's secret weapon wasn't explosive. It was chemistry, using abandoned farm equipment and spare brewery pipes. He had devised a time delivery system that sprayed this agent under pressure. When a Tiger's treads rolled across a hidden tripwire, a thin copper line ruptured, releasing vapor that ignited on contact with exhaust heat. Within seconds, the corrosion destabilized the tank's lower chassis. Bureau of Ordnance Field Report, 1944. Pierce's team reconstructed the mechanism in the barn. They found bicycle gears used as timers, tin cans as reservoirs, and tractor starter solenoids acting as detonators. Each device weighed less than 12 pounds but could cripple 50 tons of steel. Ingenious, Pierce later wrote. A field-born inversion of industrial war. Detroit Arsenal Engineering Log, 1944. German analysis reached similar conclusions, but with greater alarm. Their engineers concluded these were localized chemical sabotage devices, not mines. The report, stamped Geheim, warned that chemical degradation of mechanical integrity renders armor advantage null. Here's Waffenham Technical Evaluation, 1944. For men who trusted metallurgy, it was a humiliating revelation. They'd been undone by barnyard science. To understand why it worked so effectively, one must look at the Tiger itself, an apex predator of steel, but a fragile beast beneath. Weighing 57 tons, powered by a Maybach HL230 engine, producing 700 horsepower, it consumed nearly 500 liters of fuel per 100 kilometers and relied on delicate rubberized track pads. Armor thickness reached 100 millimeters at the front, but its undercarriage fuel lines and seals remained vulnerable. German Armored Vehicle Specifications, 1943. Emil had discovered that hitting a Tiger's armor was folly. Attacking its movement was genius. He couldn't pierce its hide, but he could rot its legs. When the first device succeeded, he refined the formula, experimenting with detergent bases and fertilizer compounds scavenged from depots. A chemist who had once taught again identified nitrates as the key accelerant. Together, they transformed farm supplies into anti-tank alchemy. Belgian Resistance Chemistry Report, 1944. As word spread, Allied ordnance officers proposed formal replication. Under Operation Harvest, Pierce's unit began testing small-scale chemical ambushes using controlled sprays rather than explosives. The test confirmed that under battlefield conditions, mud, oil, and heat, the formula weakened gaskets and track joints within minutes. U.S. Chemical Warfare Branch Test File, 1944. The Germans struck back fast. Days later, a patrol of the 9th Panzer Division entered the same valley, expecting to find resistance fighters. Instead, they found fields lined with new devices, this time booby-trapped with delayed charges. The engagement that followed would etch Emil's name into Allied lore. Allied Dispatch, October 17, 1944. At 7:40, 6 Tigers and 4 Panthers entered the zone. Emil and 3 local volunteers waited behind hedges, armed only with detonator cords and field glasses. The lead Tiger rolled forward. The first trap triggered. A geyser vapor hissed up, and the tank ground to a halt. Within 30 seconds, its track seized. A secondary blast tore through its engine compartment. The Panther behind it veered off-road and detonated another device. Smoke, thick and gray, swallowed the line. Bureau of Ships Report, 1943. For 10 minutes, the valley was chaos. Engines roaring, shells whistling, fields burning. Emil's team moved between ditches resetting triggers, slipping through mud as 88mm rounds cracked overhead. A volunteer, Andre Roux, later testified that Emil shouted coordinates to unseen Allied observers over a makeshift field radio tuned to British frequencies. Minutes later, P-47 Thunderbolts streaked low and strafed the crippled tanks. Air Support Coordination Log, October 17, 1944. When the smoke cleared, the field was littered with 8 destroyed tanks and hundreds of scattered shell casings. The farmers' devices had immobilized the enemy long enough for air power to finish the job. Allied troops moved in by noon, documenting the site for intelligence training films. Signal Corps Motion Picture Record, 1944. Back in Germany, the incident triggered panic within Armored Command. Engineers debated the sudden vulnerability of their elite weapon. Tigers must not rest near agricultural compounds, one directive read. Chemical sabotage suspected in Western Front incidents. Oberkommando de Heer's directive, 1944. Some commanders began ordering their crews to wash vehicles with alkaline water every morning, an absurd ritual in the midst of war. Meanwhile, Allied engineers refined the discovery. They adapted the concept into portable degradation sprayers, compact units deployable by partisans. These were never mass-produced but represented a turning point in thinking. Proof that asymmetric ingenuity could nullify the most powerful machine on Earth. Combined Allied Research File, 1944. When interrogated after liberation, Emil reportedly said, dramatized composite, "I just wanted them gone. My land was choking on their weight. If a cow could drag a plow, why couldn't a farmer drag a tank into the earth?" Civilian Interrogation Record, 1945. His tone was weary, not proud. For him, each burnt husk was both victory and ruin. The technical teams documented his invention meticulously. Schematics, formulas, and film reels stored under the code name Rust Storm. Historians later debated its true scale. Some argued that Allied air power was decisive. Others insisted that without a mobilization, the airstrikes would have missed their chance. U.S. Strategic Bombing Survey, 1946. What mattered most was the idea that in an age of industry and armor, intellect and improvisation still ruled. In that muddy valley, chemistry had outsmarted engineering, and the roar of 12 Tigers was silenced by a farmer's hand. Yet the victory carried a haunting question. If one man could unravel machines so mighty, what did that say about the machines guiding all of humanity toward destruction? The next months would reveal just how far the shockwaves of Emil's weapon would travel. through laboratories, command briefings, and the moral fabric of war itself. Psychological Warfare Division Report, 1945. In the months that followed, Emil Kessler's improvised triumph transformed from a battlefield curiosity into a subject of scientific and strategic obsession. His devices, initially dismissed as flukes, were now meticulously recreated in Allied laboratories from London to Washington. Engineers examined each sample, noting how corrosion began not explosively, but subtly eating at the Tiger's innards like a sickness spreading through veins of steel. U.S. War Department Technical Summary, December 1944. By early 1945, Allied staff officers realized the implications extended far beyond one Belgian field. The rust storm principle, as Detroit Arsenal analysts called it, exposed an unspoken truth that Germany's technological supremacy was only as strong as its logistics, and that armor without maintenance was nothing but metal waiting to die. The Wehrmacht's myth of invincibility was corroding, chemically and psychologically. U.S. Strategic Bombing Survey, 1946. German interrogations later revealed an acute sense of dread spreading among their tank crews. "We trusted our machines more than our luck," one prisoner admitted. Then the machines began to fail. Dramatized composite, Allied POW transcript, March 1945. Maintenance units found themselves overrun by fear and superstition. Mechanics scrubbed fittings with vinegar and carried talismans. To them, the unseen hand of sabotage had become a ghost in the machinery. Bundesarchiv, 1945. The Allied Propaganda Bureau seized the opportunity. Pamphlets dropped over enemy lines hinted at new Allied acids capable of eating through German armor overnight. The effect was electric. Rumors spread faster than truth, and field commanders began diverting resources to needless cleaning rituals. An engineer's invention in a farmhouse was now rewriting frontline morale. Psychological Operations File, 1945. Meanwhile, Emil himself remained hidden, working under assumed identity in a resistance safe house near Namur. He was haunted by what his devices had unleashed. Soldiers came to shake his hand. He refused them all. "It's not victory," he reportedly said. "It kills the soil it was meant to save." Dramatized composite, Resistance Oral Testimony, 1945. His statement echoed through debriefings, a reminder that innovation in war always bears moral corrosion alongside technical brilliance. When the front collapsed in 1945, Allied technical teams under the Combined Intelligence Objectives Subcommittee, CIOS, pursued the remnants of German tank research. Among their findings were internal memos referencing Kessler-Bedrohung, the Kessler threat. These reports detailed emergency measures, new polymer seals, replacement hoses, and decontamination kits. The mighty Tiger, once an unstoppable juggernaut, was now a symbol of overengineering brought low by agricultural chemistry. Here's Waffen memo, April 1945. At the same time, American and British chemical engineers extrapolated Kessler's principles into peacetime industries. His concept of reactive decay informed corrosion-resistant coatings, de-icing fluids, and even early fuel stabilizers. "War," one Detroit chemist wrote, "has taught us to respect rot as much as rust." Detroit Arsenal Engineering Archive, 1946. But the true legacy lay deeper, in the psyche of modern warfare. The idea that a single individual working with rudimentary tools could unmake a symbol of industrial dominance struck strategists like revelation. Post-war U.S. Army lecturers cited Kessler's case in discussions of asymmetric innovation, how simplicity and adaptability could counter technology. Army Staff College lecture notes, 1947. In 1950, as the Cold War dawned, that lesson resurfaced. American military planners studying potential Soviet armor concluded that agility, not armor, would define the next era. Out of this thinking emerged a doctrine valuing mobility, logistics, and quick repair cycles over brute force, a philosophy that would echo through Korea, Vietnam, and the Gulf. U.S. Army Mobility Doctrine Brief, 1950. Emil never sought recognition. Records show he declined official commendation twice and requested anonymity in post-war publications. Yet within classified circles, his blueprints were referenced in corrosion warfare studies, influencing decontamination systems and fuel line design. The farmer who destroyed 12 tigers had inadvertently seeded modern materials science. War Materials Research Board Summary, 1948. As for Germany's perspective, post-war debriefs revealed disbelief shading into respect. We were defeated not by stronger weapons, a captured Panzer commander admitted, but by minds that refused to surrender. German Officer Debrief, 1946. That acknowledgement, quiet and unpublicized, became a moral postscript to a war driven by machines. That intellect, improvisation, and defiance could erode any empire's armor. In the quiet years that followed, Emil returned to farming. His land bore scars, cratered soil, blackened hedgerows, warped metal half-buried like fossils of an age gone mad. He rebuilt without ceremony. Locals recall him repairing a plow with the same hands that had built his weapons, the same precision, the same silence. Local Parish Record, 1948. When interviewed late in life, he spoke rarely of those days. "I fought the tigers," he told a visiting journalist, "but I was never their enemy. The earth was." Dramatized composite. Post-war interview notes, 1962. His words lingered in archives and classrooms, cited by historians exploring how ordinary people turn survival into science. His legacy endures not as legend, but as lesson. The Kessler incident became a cornerstone in studies of improvisational warfare. Proof that no machine, however advanced, can outlast the creativity of desperation. His invention taught militaries that maintenance, chemistry, and morale were as decisive as any gun barrel. Modern Warfare Review, 1971. In the end, Emil's secret was never truly a weapon. It was an understanding. Steel fears fire, but engineers fear corrosion. Empires rot not from the outside, but from within. On a rain-swept morning in 1944, a farmer reminded the world of that truth. And so, as modern tanks roar across new frontiers, wrapped in sensors and armor smarter than men once dreamed of, they still carry within the ghost of a Belgian field a whisper that ingenuity, not industry, decide the fate of war. Because in every age, somewhere, someone like Emil Kessler is listening to the soil, turning survival into science, and proving again that even giants can rust. Historical Documentary Closing Statement, 1973.